Hello students, in this video we are going to discuss a model question paper of Karnataka CET chemistry. So this model paper questions are very helpful for the NEET exam also. Let us start with the first question. The first question is aqueous solution of salt A forms dense white precipitate with barium chloride solution. The precipitate dissolves in dilute HCl to produce gas B which decolorize acidified potassium permanganate solution. So here A and B we need to identify. So the gas which decolorize potassium permanganate is sulfur dioxide gas. So B is sulfur dioxide. We need to find out A, salt, which forms a white precipitate with barium chloride. So salt A is sodium sulfite, which on reacting with barium chloride produce a white precipitate of barium sulfite. This barium sulfite dissolves in dilute HCl to produce sulfur dioxide gas. So answer is A is sodium sulfite and B is sulfur dioxide gas. Let us go to the next question. Bond angle in pH4 plus bond angle is more than that of pH3. pH3 is phosphine. In pH3 you can find lone pair bond pair repulsion. That's why bond angle in pH4 plus is more. Let us go to the next question. Incorrectly matched pair. So here XeF6 is octahedral, XeO4 is square pyramidal, XeO3 is pyramidal, whereas XeF4 is not tetrahedral. This is incorrectly matched because in XeF4 xenon shows sp3d2 hybridization with 4 bond pair and 2 lone pair. That's why XeF4 structure geometry will be square planar, not tetrahedral. Phosphorus pentachloride PCl5, phosphorus pentachloride on hydrolysis gives one oxo acids of phosphorus and this oxo acid is tribasic. So option C is right answer for this question. Identify the set of paramagnetic ion. Paramagnetic ions means the ions which slightly attracted to the magnet, and the reason behind attraction is unpaired electron. So option A containing ions Ti3 plus, Cu2 plus and Mn3 plus has one or more unpaired electron. That's why they show paramagnetism. Potassium dichromate. How many moles of potassium dichromate required to liberate 6 moles of iodine from the aqueous solution of iodide ion? So as this equation shows, so 1 mole of potassium dichromate on reacting with potassium iodide liberates 3 moles of iodine. So according to the question, to liberate 6 moles of iodine, there must be 2 moles of potassium dichromate. So 2 is the right answer. Seventh question, Cu2Cl2 and CuCl2 in aqueous medium. In the aqueous medium, CuCl2 is more stable. Why this is? It depends on hydration enthalpy. So as you can see here, CuCl2 is more stable because the size of copper ion is smaller than Cu plus ion. So on the smaller the size of the cation, it will be the hydration enthalpy and more stable. So Cu2 plus, as it is smaller in size, it is more stable. So the coordination number of iron and cobalt in the following complexes. In this complex, iron is surrounded by oxalate ion and this oxalate ion is bidentate ligand. So here the coordination number of iron is 6, and in second case thiocyanate is monodentate ligand. That's why its coordination number is 4. So 6 and 4 is the right answer. So another question from coordination compounds chapter, the number of stereoisomer exhibited by this coordination complex. So this coordination complex can exhibit 2 cis isomers and 1 trans isomers. That's why it will exhibit 3 stereoisomers. Another question from coordination compounds, the IUPAC name of this complex is tetraamine platinate 2, tetrachloride platinate 2. One more question from haloalkanes and haloarenes, prolonged exposure of chloroform in humans may cause damage to the liver. It is due to the formation of phosgene, carbonyl chloride, phosgene, COCl2 gas. That's why we need to store the chloroform in dark colored bottle. Another question from haloalkanes and haloarenes, which of the following halides shows highest reactivity towards SN1 mechanism? In SN1, so here among the 4 options, this particular benzyl chloride shows more reactivity because it is going to form stable carbocation due to resonance. This is showing, it is going to show stable cation. In the next question, there is a reaction of Grignard reagent with amine. One primary amine in the presence of dry ether. Definitely there will be a formation of hydrocarbon, that is alkane. So as you can see here, Grignard reagent on reacting with methanamine in the presence of dry ether, it produces propane. This propane shows 2 possible isomer. So it is butane, isobutane. So Grignard reagent, this particular Grignard reagent on reacting with methylamine, it produces isobutane or 2-methyl propane, and one more isomer of isobutane is butane. So it is going to possibly form 2 types of chain isomers. Next question. In the next question, we have some options here, PQRS, which among the following on heating gives ether. ether. So we need to find out among the four options which are going to form a ether. So by Williamson's ether synthesis, P and Q, by Williamson's ether synthesis, P and Q can able to produce ether because one has primary alkyl halide, another has benzyl halide. So primary alkyl halide and benzyl halide on reacting with sodium methoxide or sodium phenoxide both can able to produce ether, which follows SN2 mechanism, and this reaction is known as Williamson's ether reaction. So both P and Q is the right answer for this question. In the next question, what we can find is the steps involved in the conversion of propan 2-ol to propan 1-ol. We need to convert propan 2-ol to propan 1-ol. So propan 2-ol is a secondary alcohol. We need to convert into primary alcohol. For that, propan 2-ol secondary alcohol on treating with phosphorus pentachloride, it gives 2-chloropropane. This on treating with alcoholic KOH, it undergo beta elimination, dehydrohalogenation to produce alkene, propene. This on treating the hydroboration, oxidation hydroboration, it gives a propan 1-ol. So heating with phosphorus pentachloride and with alcoholic KOH and followed by hydroboration oxidation, we can able to convert propan 2-ol to propan 1-ol. In the next question, which of the following is the strongest base? Of course, OH minus ion is the strongest base. It's an easy question. 17th question, identify the product P in the given reaction. So this is one benzaldehyde and this is ethanol. So ethanol has alpha hydrogen. So because of alpha hydrogen in the presence of NaOH, both undergo aldol condensation to produce one aldol intermediate. On heating by dehydration, it gives this product. So option A is the right answer. In the next question, which of the following has lowest boiling point among amines, alcohol, carboxylic acid and ether? Ethers have lowest boiling point because they are unable to form hydrogen bonds. That's why they have lowest boiling point. The carbonyl compound that does not undergo aldol condensation, among the given four option, the one that does not have alpha hydrogen is not able to undergo aldol condensation, and the not having alpha hydrogen among the four option is trichloroacetaldehyde. This will not undergo aldol condensation. In the next question, directly I have given the answer. Nitrobenzene on bromination gives meta-bromo-nitrobenzene. This on treating with tin in the presence of concentrated HCl, nitro group undergo reduction to produce amine group. So Q is an amine. That amine on treating with NaNO2 in the presence of HCl and 0 to 5 degrees Celsius, it undergo diazotization to produce diazonium salt. This diazonium salt on hydrolysis, it converts into alcoholic group. So R is this product. So this is the interconversion reaction, very important one. Hinzberg reagent, of course, is benzene sulfonyl chloride C6H5SO2Cl2, and this Hinzberg reagent is used to differentiate primary, secondary and tertiary amines. Next question also very easy. Vitamins not stored in adipose tissue is B6 because B6 is vitamin B a part which is water soluble, and D, E, A are the fat soluble vitamins, so they can store. B6 cannot be stored. Hypothyroidism is caused by the deficiency of thyroxine hormone, and thyroxine hormone is produced by thyroid gland. C1 C4 glycosidic linkage is not found in sucrose because in sucrose we can find C1 C2 glycosidic linkage, not C1 C4. The food additive that also acts as antioxidant is a butylated hydroxyanisole BHA. Which of the following is not related to drug enzyme interaction? The drug enzyme interaction is not involved in antagonist. Let us go to the one numerical question. 0.4 grams of dihydrogen. 0.4 grams of dihydrogen. So if you divide mass by molar mass of hydrogen is 2, you will get number of moles 0.2. And 7.1 gram of chlorine, dichlorine Cl2. 7.1 gram of chlorine, mass by molar mass of chlorine is 71. You will get 0.1 mole. So the volume of hydrogen chloride formed, we need to find out according to this equation. We need to find out the volume of HCl formed when 0.4 grams of hydrogen and 7.1 grams of chlorine reacts. So according to the reaction, 1 mole of hydrogen combines with 1 mole of chlorine. So 0.2 moles of hydrogen must combine with 0.2 moles of chlorine, but in the question they have given only 0.1 mole. So here chlorine is a limiting reagent. So as chlorine is a limiting reagent, what we can suggest is 0.4 grams of dihydrogen, that is nothing but 0.2 moles of dihydrogen, will able to give double than that of HCl. So as chlorine is a limiting reagent, we need to find out volume of HCl formed at STP. So hence 0.2 moles of hydrogen produce 0.2 moles of HCl because chlorine is a limiting reagent. We need to find out the volume of HCl at STP. So 1 mole of any gas at STP is equal to 22.7 liters. Thus, if 1 mole is equal to 22.7, then 0.2 mole is equal to 4.54 liters. Next question, with regards to photoelectric effect, the correct statement is number of electrons ejected increases with increasing the intensity of incident light. So the conjugate base of NH3 conjugate base is NH2 minus, because conjugate base has one proton less from the acid. If we consider NH3 as an acid, then conjugate base must be having one proton less, so one H plus less. So NH2 minus is the right answer. Next numerical, we have a gas mixture contains 22% helium and 74% methane. So this is by volume. So now we know the standard volume of any 1 mole of a gas is 22.4 liters. That's why you divide the volume 25 volume of helium with its 22.4, you will get the number of moles 1.12. Similarly, helium molar mass is 4. When you multiply, you can convert into mass. Okay, moles into mass, 4.4 grams, 4.48 grams. Similarly, methane percentage is 75 divided with the volume of 1 mole 22.4, you will get 3.35 moles. Now methane molar mass is 16. When you multiply, you will get 53.60. So when you add 53.60 and 4.8, both mass of helium and methane, you will get 58.08. So if you want to find out the mass percentage of methane, the mass of methane 53.60 divided by the mass of overall mass of the compound with methane and the helium 58.08 into 100, if you do, you will get 92.28%. Like this you can calculate. So the percentage of S character in NO2 plus, NO3 minus, NH4 plus. So in NO2 plus, the nitrogen shows sp hybridization. So in sp hybridization, the percentage of S character is 50%. The percentage of S character is 50%. In NO3 minus, the nitrogen has sp2 hybridization. So in sp2 hybridization, the percentage is 33.33%. And in NH4 plus, the percentage of the hybridization of nitrogen is sp3, and in sp3 the percentage of S character is 25%. So option A is the right answer for this question. Next question, the formal charge of central oxygen in ozone central oxygen in ozone is +1. Next question, when the same quantity of heat is absorbed by a system at two different temperatures T1 and T2 such that T1 is greater than T2, the entropies are delta S1 and delta S2 respectively. So we know that in thermodynamics the concept of entropy S changed due to transfer of heat, which we can write in the form of delta S is equal to Q by T. So in this question, heat is constant, Q is constant. So delta S is inversely proportional to temperature. Delta S is inversely proportional to temperature. Because of that, as T1 is greater than T2, the actual relation between entropies is delta S2, final entropy is greater than initial entropy. So option C is the right answer for this question. The oxidation number of NH4NO3, ammonium nitrite, when you dissociate, you will get NH4 plus. So in NH4 plus, if you calculate, the oxidation number of nitrogen is -3, and in NO3 minus, the nitrogen oxidation state is +5. So option D is the right answer. The Lewis acid reacts with lithium aluminum hydride in ether medium to give a highly toxic gas. This gas on heating with ammonia gives a compound known as inorganic benzene. So inorganic benzene definitely produced by diborane only, B2H6 is the answer. So oxide of potassium that does not exist. Potassium can form K2O2, K2O and KO2 oxide, superoxide and peroxide, but it cannot form K2O3. The metal that produces hydrogen with both dilute HCl and NaOH is zinc. So next question is, which of the following is not a pair of functional isomer? So definitely, so option C, as both are ethers, so it cannot be a functional isomers. In the next question, what we can find is benzene on treating with chlorine in the presence of anhydrous aluminum chloride, it gives ortho and para dichlorobenzene. So ortho dichlorobenzene in the presence of excess of chlorine, it will form hexachlorobenzene. So next question, which of the following is not a greenhouse gas? Of course, oxygen is not a greenhouse gas. Next, electrochemistry question, a pair of electrolyte that possess same value for the constant A in Debye-Huckel's Onsager equation. So among the four options, NaCl, NH4Cl and NaBr both are forming only mono type of cations, NH4 plus, Cl minus, Na plus, Br minus. Whereas in the remaining options, you can find difference in the valencies. That's why option D is right answer, which gives same value. Next question from chemical kinetics, electrochemistry itself. So here in this question, there is a numerical. E0 of iron is 0.76 volt and E0 of iodine is 0.55 volt. The equilibrium constant Kc we need to find out. So we know the relationship. We have to find, first of all, we need to find out E0 cell by using the formula E0 of cathode minus E0 of anode. So in this given question, cathode is iron, of course, you substitute the value, and anode is iodine. So when you subtract, you will get electrode potential of the cell 0.21. Now you write down the redox reaction, you will come to know the number of electrons. The number of electrons, of course, 2, Fe3 plus to Fe2 plus. Oxidation or reduction, you take n number of electrons is 2. Now you can write down the final formula. E0 cell is equal to 0.0591 divided by n log of Kc. N is 2 is the number of electron, log of Kc. So when you calculate log Kc, you will get 7. That is nothing but Kc is equal to 10 to the power of 7. 1 into 10 to the power of 7. In the next question, in the aqueous solution of NaF is electrolyzed between inert electrode, the product obtained at anode. So aqueous solution, as we are taking aqueous solution among F minus and O2 minus, oxygen is going to discharge at anode, so it will release oxygen gas in this case. So oxygen is released. In next question, in which of the following cases chemical reaction is possible? So whereas here in the first option, platinum and gold both are inert, they won't react. And when it compared to zinc sulfate and copper, so zinc sulfate is placed in copper as zinc is more reactive than copper, so there also reaction will not happen to take place. Copper will not displace. When it comes to AgNO3 solution is stirred with copper spoon, as copper is more reactive, so copper can able to displace silver from the silver nitrate. So here chemical reaction is possible in option D. Next question is of chemical kinetics, the time required for the 60% completion of the first order reaction. So for the 60% completion means, first order reaction is 50 minutes. The time required for 93.6% completion of the same reaction will be. So for 60% completion, time is 50 minutes. We need to find out for 93.6% completion how much time it is going to take. So first order reaction formula, you know it, K is equal to 2.303 divided by T log of initial concentration of the reactant minus final concentration of the reactant. In first case, 60% completed means 60% completed means 40 will be remains, log R naught is 100 and R is 60 minus 100 minus 60, which is equal to 40. Time is 50 minutes. When you calculate, you will get this value. Similarly, for 93.6%, initial concentration is 100 minus 93.6 will be 6.4. For second case, if you calculate, you will get this answer. So when you compare both, so the time taken for 93.6% completion is 150 minutes. When you solve these two cases, both this equation for 60% completion as well as 93.6% completion, when you compare both this, you will get 150 minutes. In the next question, for the elementary reaction, for this particular reaction, the rate of appearance of product C at a time t is 2.8 into 10 to the power of minus 3 mole per liter per second. The rate of disappearance of B. So rate of appearance has been given. We need to find out the rate of disappearance of B. So as the B is disappeared, B is reactant. So it is in the balanced equation, it is 3B. So we need to write minus 1 by 3 dB by dt is equal to, and C is product, it is increased by 4 times. So we need to write plus 1 by 4 dC by dt. So when you substitute both this 1, you will get 3 by 4 into 2.8 into 10 to the power of minus 3 mole per liter per second. So substitute both the values here. So minus 1 by 3 dB by dt is equal to 1 by 4 dC by dt. When you calculate, you will get minus dB by dt is equal to 3 divided by 4 dC by dt. So when you calculate, you will get 3 by 4 into 2.8 into 10 to the power of minus 3. In the next question, the rate constant of a reaction is given. K is equal to P ZE to the power of minus EA by RT under standard notation. In order to speed up the reaction, which of the following factor has to be decreased? So if you want to speed up the reaction, energy of activation, you need to decrease. So these are some of the question answers from first PC and second PC chemistry. I hope it is going to be very helpful for your revision. Thank you, students.